Two of the most talked about fields in modern technology are quantum computing and artificial intelligence. Both promise to reshape the world as we know it, and both attract some of the brightest minds on the planet. But if you are trying to decide which path to pursue, or simply want to understand how they stack up against each other, the differences are more fascinating than you might expect. These are not just two branches of computer science. They represent entirely different ways of thinking about problems, mathematics, and the future of human knowledge. When it comes to raw difficulty, quantum computing sits at a noticeably steeper learning curve. To genuinely understand quantum computing, you need a strong foundation in quantum mechanics, linear algebra, complex numbers, and probability theory at a graduate level. You are essentially learning a new model of physical reality before you even write a single line of code. Artificial intelligence, while certainly challenging, is more accessible at the entry level. You can begin building functional machine learning models with a solid grasp of calculus, statistics, and linear algebra. The ceiling in artificial intelligence is incredibly high, but the floor is much lower, meaning more people can get started without years of specialized physics training. The mathematical demands of these two fields are quite different in nature. Quantum computing relies heavily on concepts like superposition, entanglement, Hilbert spaces, and unitary transformations. These ideas come directly from quantum mechanics and require comfort with complex valued matrices and Dirac notation. Artificial intelligence, on the other hand, leans on multivariable calculus for backpropagation, probability, and statistics for model evaluation, and linear algebra for understanding neural network operations. Both fields demand mathematical maturity, but quantum computing demands a deeper understanding of physics-based mathematics, while artificial intelligence demands a broader and more applied mathematical toolkit. From a coding perspective, artificial intelligence has a massive advantage in terms of available resources. Frameworks like TensorFlow, PyTorch, and scikit-learn make it relatively straightforward to implement complex models with just a few hundred lines of Python. The community is enormous, documentation is rich, and tutorials are everywhere. Quantum computing, by contrast, uses frameworks like Qiskit, Cirq, and PennyLane. These tools are growing rapidly, but the ecosystem is far less mature. Writing quantum circuits requires understanding gate operations, qubit manipulation, and noise management, concepts that have no direct parallel in classical programming. The debugging process alone can be deeply counterintuitive because quantum states cannot be directly observed without collapsing them. Career opportunities in artificial intelligence are abundant right now. Roles in machine learning engineering, data science, natural language processing, and computer vision are available across virtually every industry. Salaries are competitive, demand is high, and the job market continues to grow at a rapid pace. Quantum computing careers, while incredibly exciting, are still emerging. Most positions exist within research institutions, government agencies, and a handful of technology companies like IBM, Google, and startups focused on quantum hardware and software. The salaries can be exceptional, but the number of available roles is significantly smaller. However, as quantum hardware matures over the next 10 to 20 years, this is expected to change dramatically. Choosing between quantum computing and artificial intelligence ultimately comes down to your interests and long-term goals. If you love physics, enjoy abstract mathematical thinking, and want to work on problems that will define the next century of computing, quantum computing offers a rare and thrilling frontier. If you want immediate impact, a thriving job market, and the ability to build tools that affect millions of people today, artificial intelligence is the stronger choice. Both paths are extraordinary. The real question is, which kind of extraordinary speaks to you?